Hi algebra students, we are going to take some notes today on special products of polynomials. So the process for these are the same as what we did for multiplying binomials. It's just that we're going to look for some special patterns with these binomials and what they look like, and then what their product looks like. And it might just be that you're able to recognize that certain binomials are special, and so you can easily figure out what their product is going to be without having to do the multiplication. So the materials you will need for these notes is you will need your a math notebook or paper, pencil, and a calculator if you need help with some of the multiplication, but we will not be doing any graphing. So gather your materials and let's get started. Okay, follow along with me. Take notes just like you would in class. This is chapter 7, section 4 in your book if you want to go back and look over any of that material. So, some pairs of binomials show patterns when multiplied. You can use these patterns to multiply other similar pairs of binomials. So the first kind we're going to look at has this pattern of A plus B times A minus B. And if you see two binomials that have this pattern, it's always going to be, your answer is going to be an A squared minus B squared. And we're going to go ahead and show why that's true. So for example 1, we are going to find the product of x plus 7 and times x minus 7. Now notice it's following this pattern. We have the same numbers and variables and then plus and minus. So we're going to do, I'm going to draw my area model to help me figure this out, and that will kind of prove my pattern. So I'm going to do an x plus 7 over here and an x minus 7 on top. Now I'm going to go ahead and multiply. I got x squared. 7 times x is 7x. 7 times x times a negative 7 is negative 7x. And then I get a negative 49. So I notice that I end up with an x squared minus 7x plus 7x minus 49. So when I combine like terms, my final answer is going to be an x squared minus 49. And you see how my answer here follows this pattern that we got up here. Let's look at another example together. So example 2. Now let's look at what if it is a 3x minus 1 times a 3x plus 1. So let's set up our area model. Just help us figure this out and prove that it fits our pattern here. So we have 3x minus 1 and 3x plus 1. So I do my multiplication and I get 9x squared. And 3x times negative 1 is a negative 3x. 3x times 1 is a positive 3x. And negative 1 times positive 1 is a negative 1. So I end up with a 9x squared plus 3x minus 3x minus 1. And combine like terms, I end up with a 9x squared minus 1. Okay, so again, if you notice this pattern in the binomials, you can skip the multiplication using the area model or any other method you like, and you'll know that your product is going to follow this pattern. But if you come across a problem of a special product and you don't recognize it right away, then you'll just go through the process and you'll end up with the same answer. So it's basically, this section is just if you notice the binomials are special products, then it just saves you some time when you're doing the multiplication. So now it's time for the you try section. So I'm going to write some problems down. You're going to pause the video. You're going to try them. you'll press play to check your answers. Okay, so we will do x minus 4 times x plus 4. Second one will be b plus 10 times b minus 10. And then I ran out of room there, so I'll write it down here. Our third one will be 2g plus 5 times 2g minus 5. Okay, so go ahead and if you're not sure how to do these, if you're having trouble with 1 and 2, go back to our example 1. If you're having trouble with number 3, go back to example 2, rewatch that part of the video, come back, press play when you have your answers. Okay, I'm going to reveal answers to you, so you should have tried these on your own already. Our first one, the answer should be x squared minus 16. The second one, your answer should be b squared minus 100. And our third, you tried, the answer you should have gotten is 4g squared minus 25. All right, so if you were not able to get any of those answers correct, go back, watch example 1 and example 2 again in this video, or send me a message and I will happily help you out. Okay, let's go on to our next example. I need to grab a new piece of paper. So here we go. So the next set of special binomials are going to follow this type of pattern of a plus b squared, okay? And if we see something like this, we know that we're always going to get a product of a squared plus 2ab plus b squared, okay? And then the second one is if we ever see an a minus b squared, we know that we will always get an answer that looks like a squared minus 2ab plus b squared. Okay, so we're just going to go ahead and prove this is called a square of a binomial. So this is the type of pattern that you could notice. So this is example 3. So example 3 is, let's try y plus 1 squared. So we know that this is going to equal, or is the same as, y plus 1 times y plus 1. So I'm going to use my area model to see how this works out. But again, if you notice the pattern right away, you wouldn't have to use the area model. Plus 1, y plus 1. So I got y squared, y times 1 is y times 1 is y, 1 times 1 is 2. So I get y squared plus y plus 2. So my final answer, forgot to switch up my colors during that one. I got y squared plus 2y plus 2. Okay. We'll do one more example together. And then I'll give you some problems to try on your own. So 2z minus 3 squared. So we know that this is going to be 2z minus 3 times 2z minus 3. Okay, so I know that if I see the square there, it means that I have two binomials that look exactly the same. So I'm going to set up my area model to assist me in figuring this out. So I get 2z minus 3 and 2z minus 3. And switch up my colors. So 2z times 2z is 4z squared. 2z times negative 3z is a negative 6z. The same thing over here, 2z times negative 3, negative 6z. Negative 3 times negative 3 gets me a positive 9. So over here I get 4z squared minus 6z minus 6z plus 9. Combine like terms, and my final answer is going to be a 4z squared minus 12z plus 9. Okay, so I notice that this is what my binomial looks like to begin with. It has a subtraction in the middle and is squared. So I know that my answer is going to follow this pattern, a squared minus 2ab plus b squared. So I see that I got a is 2, so that's how I get that 4z squared. And then minus, so I know I'm going to have a minus in the middle for my middle term. And then 2 times a times b. So that means 2 times 2 times 3, which is that negative 12. And then my last term is going to be a b squared. My b term is a 3. When I square that, I get 9. Now this just sounds, I know, can sound confusing. So again, I just wanted to show you that some of these patterns exist so that you can do these problems quicker. But if you are totally confused, not ready to recognize some of these patterns, then just use our area model and you get the same answer. Okay, you get the same answer in the end. I'm going to give you some U-try problems, and that will be the end of our notes. So for some U-tries, let's do this. So U-try, I'm going to give you 4 to try. Okay, so I want you to do w plus 2 squared. And how about x minus 7 squared? 3y minus 1 squared. And 5z plus 4 squared. So if you are already not sure how to start these, rewatch example 3 and 4 in this video. If you're ready, go ahead and pause so you can try these, and then I'll reveal the answers. Okay, here are the answers to our U-try problems. So you should have already tried these on your own. So this one, we should get w squared plus 4w plus 4. This one should be x squared minus 14x plus 49. This one, 9y squared minus 6y plus 1. And our last one, 25z squared plus 40z plus 16. Okay, so if you aren't sure about how we got those answers, again, you can always rewatch part of this video. You can join me during office hours. You can send me an email. Please reach out if you are having trouble with this concept. I am here to help. If you are good to go, then go on to do some of the practice this week. And, I'll see you guys in a Google Meet sometime soon.